Hello, welcome to class. In this class, we'll be solving past paper questions for AS level Excel on trigonometry identities. So we're going to solve for a few questions. These are past paper questions already compiled. Number one said we are going to be solving without your calculations. We are going to the solutions are based entirely on graphical or numerical methods are not acceptable in this question. So we don't need a graph, we don't need numerical method. So in this aspect, we are going to be applying our trigonometry identity to solve for this question. So once they solve for 0, the equation 3 sine base equals to this. So I'll bring the question down. 3 sine 2 theta minus 10 degrees equals to 1. So this is a straightforward question. What I'll do, I'll just divide both sides by 3. I want to eliminate the 3 from this side. This gives sine 2 theta minus 10 equals to 1 over 3. So I want to remove the sign from here. It gives 2 theta minus 10 is equals to sine inverse of 1 by 3. That gives 2 theta minus 10. So you do shift and sign on your calculator for sine inverse of 1 over 3, which will give me 19.47. So note the values of sine are 2, because the sign is positive on your second quadrant if you are going either clockwise or anti-clockwise, second quadrant or fourth quadrant. So that gives us 180 minus 19.47 to get the second angle of your sine theta. And this gives us 160.53. So my sine inverse of 1 over 3 is 19.47 or 160.53. So that's 2 theta minus 10 equals to 19.47. I'll be using the two values. So 2 theta will be 19.47 plus 10. This gives 2 theta as 29.47. So dividing by 2, I have my theta as 4.7 degrees. Or substituting 160.53 as theta, we're also going to have 2 theta minus 10 equals to 160.53. That gives 2 theta as 160.53 plus 10. 2 theta will give 170.53 divided by 2. My theta value will give 85.2.2. We have 6 degrees here, so which approximately can be 85.3 degrees. So this is how to go about solving this question. Then we'll move to the next part of the question. It says the first term of an arithmetic sequence as sine theta, 1 over tan theta, and 2 sine theta, where theta is a constant. We are asked to show that 2 cos theta equals to what? 3 sine square theta. That is, we are going to show this from this. So I'm going to show that 2 cos theta is equal to 3 sine square theta. How do we go about this? We know that for an AP, we have what we call a common difference. And our common difference is the second term minus first term, or the third term minus the second term, or fourth term minus third term. So this is how we get the common difference. So simply what I'm going to have here, this is my first term, which is the A, second term, this is my T2, and this is my third term. So I'll do T2 minus T1, which is 1 over tan minus sine. This is equals to 2 sine theta minus 1 over tan theta. This is what we call the common difference of your arithmetic sequence. So this, I'll just have to simplify this. Remember tan theta from our trigonometry identities. Tan theta is equals to sine theta divided by cos theta. So have this in mind. And we have 1 minus sine squared theta, which will give us cos squared theta, or 1 minus cos squared theta will give us sine squared theta. These are the trigonometry identities you should have in mind. So I'm going to be replacing tan theta with sine divided by cos. So that will give us 1 over sine theta divided by cos theta. Okay, minus, this is my sine theta here, equals to 2 sine theta minus 1 over sine theta divided by cos theta. So flipping this, dividing this, it becomes cos theta over sine theta minus sine theta, which is 2 sine theta minus cos theta over sine theta. Then I'll have to solve for this, looking for the LCM of this, which is sine theta. So sine theta divided by sine theta gives 1. 1 times cos theta gives me cos theta. Minus sine theta divided by 1 gives me sine theta. Sine theta times theta will give me sine square theta, which is equals to the same thing I do here. I look for the LCM of this, which is sine theta. This is by 1. So sine theta divided by 1 is sine theta times 2 will give me 2 sine square theta. So this gives 2 sine square theta minus cos theta. So what do we have here? You can cross multiply this equation. This gives sine theta into cos theta minus sine square is equals to sine into 2 sine square minus cos theta. So I'll just have to eliminate this because they are both on the same side, so it's better you remove it instead of using it to expand whatever you have. So opening the bracket, I'll have cos minus sine square is equals to 2 sine square minus cos this. Okay, so collecting like terms, cos plus cos will give me 2 cos is equals to, this moves over to this place to give us 3 sine square. So we've proven the A part of it. So moving to the B aspect, I say find change all the values of this to 3 decimal places. If you want to be finding the value of that, I'll bring 2 cos theta is equals to 3 sine square theta. So I'm going to convert my sine to cos. And remember I said just now 1 minus cos square theta is equals to what? Sine square theta. So have that in mind. So that means I have 2 cos theta is equals to 3 into 1 minus cos square. This gives 2 cos equals to, as opening the bracket gives me 3 minus 3 cos square. Okay, so I'm going to make this, bring this together. I'm moving 3 to become positive to the other side. This gives me a positive 3 cos square plus 2 cos minus 3, which is equals to 0. So I have a quadratic equation. So using the quadratic formula of minus b plus minus b squared minus 4ac divided by 2a. So our b is 2. We have minus 2 plus minus 2 squared minus 4 times 3 times minus 3 divided by 2a This gives minus 2 plus minus 2 squared is 4 plus 36 over 2a. And our a here is 3. This gives me minus 2 plus minus root 40 divided by 6. So you're going to use this on your calculator. So using your rad function, I will have this as 5.57 rad. So this is the value for your theta to 3 decimal places. So let's move on to the next question, which is this. We have to show that tan theta plus 1 over tan theta is equals to 1 over sine theta cos theta. So I have tan theta here plus 1 over tan theta. So just remember, we say tan theta is sine theta divided by cos theta. So I'm just substituting for that, plus 1 over sine theta divided by cos theta. So this gives sine theta over cos theta plus this gives cos theta divided by sine theta. So looking for the LCM of this, what do we have here? I have cos theta, sine theta, or sine theta, cos theta, any of them. This gives, divided by this gives me sine theta. Sine theta times sine theta gives me sine square theta. And this divided by this gives me cos square theta. And remember we say sine theta plus cos theta, cos square theta is equals to 1. So simply that guy, we replace it 1. We have it as 1 over sine theta cos theta. So we've proven this. This is 3 marks already. So you can go ahead to solve for theta in the equation. In 3 cos square into 2x plus 10 is equals to 1. I think we have solved something similar to this. So what you just do, you divide by 3, divide by 3. Okay, so dividing by 3 here, I'll have cos square 2x plus 10 is equals to 1 over 3. So what do we have here? We have 2x plus 10 is equals to, this cos square will make me have here as root 1 over 3. Okay, so we have a positive or a negative root 1 over 3. That gives us 2x plus 10. We have cos inverse here, cos inverse of root negative 1 over 3. That gives 54.73, or we can have 180 minus 54.73, which will give us 125.27. So these are the values of my theta. Then I'll have 2x plus 10. Same thing we did previously, give us 54.73. So that gives 2x as 54.73 plus 10. 2x is equals to 64.73 divided by 2, divide by 2. So x gives 32.36. Or substitute the value of 125.7 into 27 into the value of theta, and you get the other answer for this. So let's proceed to the next question. So we are asked to show that the equation a tan theta equals to 3 cos theta may be written in the form of 3 sine theta squared plus 8 sine theta minus 3. So have 8 tan theta is equals to 3 cos theta. So I'm going to change my tan theta, so we are asked to show it as sine theta. So tan theta gives us 8 sine theta divided by cos theta. So this is equals to 3 cos theta. So what do? I have to cross multiply this. This gives 8 sine theta as 3 cos square theta. So remember, cos square theta is 1 minus sine theta. So simply I will just have to replace cos square theta with 1 minus sine square theta. Opening the bracket, I have 8 sine theta is equal to 3 minus 3 sine square theta. So you can rearrange this because we are asked to show it in this form here. So rearranging 3 sine square theta moves to give us positive 3 sine square theta plus 8 sine theta minus 3 equals 0. So this is the A aspect and this is for 3 marks. Then we move to the B aspect of the question. It says hence solve for this the equation A and 2x is equal to 3 plus 2x, giving your answer to 2 decimal places. So looking at the B aspect of the question, we have to solve for the value of x, giving our answer to 2 decimal places where 8 and 2x is equal to 3 cos 2x. So using quadratic formula or factorization, we have, I would like to factorize this. This gives me 9 sine squared theta. So the factors that will give me 8 will be 1 and 9. So I'm going to be replacing 8 sine theta with this plus 9 sine theta minus 1 sine theta minus 3. This is by factorization. So from this into 2, you can use your quadratic formula for this also. Anyone that is easy for you, you go with this. So I have 3 sine theta into sine theta plus 3 minus 1 into sine theta plus 3 equals to 0. So that gives 3 sine theta minus 1 equals to 0. So that means 3 sine theta equals to 1. Sine theta is equals to 1 over 3. Then theta gives me sine inverse of 1 over 3. Or I have sine theta plus 3 equals to 0. That means sine theta here is equals to negative 3. So theta is sine inverse of negative 3. So you can use this to find the values for theta. So, but remember, in the question, we are asked to find 2x and 2x. So this, I'll just have 2 sine 2x is whatever we have, which is 1 over 3. That means x will be what? Sine inverse of 1 over 3 divided by 2. So x will be sine inverse of 2 over 3. So this gives us 9.74 degrees. Or you have 18.26 degrees. Because of the 2x, that is why when back using 2x along with it. Show that the equation 3 sine theta cos theta over 2 sine theta is equals to 5 tan theta. Note sine theta is not equals to 1 or 2. Can be written in the form of 3 sine square theta plus this equals to 0. So same trigonometry identities, we have 3 sine theta cos theta over 2 sine theta minus 1 is equals to 5 tan theta. So I'm going to change tan theta into cos and sine, that gives sine theta cos theta divided by 2 sine theta minus 1 is equals to 5 sine theta divided by cos theta. You have to cross multiply. So this is 5 sine theta into 2 sine theta minus 1 is equals to cos theta into 3 sine theta cos theta. So we have to expand. This gives me 10 sine square theta minus 5 sine theta is equals to 3 sine theta cos theta, 3 sine theta cos square theta. So we have, this is 3 sine theta cos square theta. Remember, this is going to give me 10. Write this down, 3 sine square theta minus 5 sine theta is equal to 3 sine theta. Remember, cos theta is 1 minus sine square theta. We have 10 sine square theta minus 5 sine theta is equals to 3 sine theta multiply 1 gives 3 sine theta minus 3 sine cube theta. Okay, so collecting the equation to the other side to give me 3 sine cube theta minus plus 10 sine square theta. Then we have minus 5 plus 3 gives we have minus 5 sine theta minus 3 sine theta is minus 8 sine theta. So we are proving this, and that is 4 marks. So go ahead to solve the B aspect of it. We have solved questions related to this. So we are going to solve for this n is, so you're going to just substitute whatever values you have.